KUDINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KUDINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kudinjischoolnkl.in.
In continuation to the last class, in this class we start with 34th problem. See here, a photoelectric surface is illuminated successively by monochromatic light of wavelength lambda and lambda by 2, full stop. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that in the first case, okay, right. The work function of the surface of the material is, okay, right. See here, a photoelectric surface is illuminated, successively by monochromatic light of wavelength lambda and lambda by 2, right, full stop. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times that in the first case, okay, right. The work function of the surface of the material is, okay, right. So if you observe carefully here, we used in 2 different cases, right, a wavelength of light will be different. That is what, in one case it is lambda, in another case it is lambda by 2, okay, right. If the maximum kinetic energy of the emitted photoelectrons in the second case, that is what, in case of lambda by 2, is 3 times that in the first case. So what is this 3 times in the first case? Kinetic energy, maximum kinetic energy, right, the work function of the surface of the material. So by giving a situation, that is what, same metallic surface is exposed to the electromagnetic radiation, that is what, light of 2 different wavelengths. In one case it is lambda, in another case it is lambda by 2, okay. And he also given the relation between the maximum kinetic energy in 2 different cases, right. So that is what, in second case it is 3 times that in the first case. In second case it is 3 times that in the first case, okay, right, comma, the work function of the surface of the material is, okay, right. See this, according to Einstein's photoelectric equation, in the first case K maximum 1 is equal to hc by lambda minus phi naught, and that in the second case, right. So this relation, you know, that is what, according to Einstein's photoelectric equation, you know that E is equal to h nu naught plus Ke maximum, right. And if you write Ke maximum as a subject, you know, there itself you can say that it is Ke maximum is equal to Ke maximum or K maximum is equal to h nu minus phi naught, okay, right. So when K maximum is equal to h nu minus phi naught, and you already know that K maximum is equal to E V naught, right. So these 2 relations we already know, and based on those 2 relations, right, here, so basically that is what, K maximum is equal to h nu minus phi naught. Based on that relation, in first case it is K maximum 1 is equal to hc by lambda minus phi naught, and that in the second case K maximum 2 is equal to hc by lambda by 2 minus phi naught, that is equal to 2 hc by lambda minus phi naught, 2 hc by lambda minus phi naught, okay, right. But k maximum 2 is equal to 3 into k maximum 1. K maximum 2 is equal to 3 into k maximum 1, okay, right. So here 2 hc by lambda minus phi naught, 2 hc by lambda minus phi naught is equal to 3 into this value we have to write 3 into hc by lambda minus phi naught, okay. That implies you just do here do this multiplication. It is what 3 hc by lambda minus 3 phi naught, no, 2 hc by lambda minus phi naught is equal to 3 hc by lambda minus 3 phi naught, okay, right. That implies phi naught is equal to actually when this 3 phi naught will go that side, it is what plus, no. So 3 phi naught minus phi naught, that is what 2 phi naught, and this 2 hc by lambda will go this side, then this side is hc by lambda, right. So 2 phi naught is equal to hc by lambda, and phi naught is equal to hc by 2 lambda, hc by 2 lambda, okay. So this is what here work function, what he is asking, that we found as hc by 2 lambda. H is the Planck's constant and c is the speed of light in vacuum and lambda is the wavelength, right. So based on these three things we have found phi naught as hc by 2 lambda, hc by 2 lambda, okay, right. So regarding this problem, that is what when a particular metallic surface is exposed to two different wavelength of light, so one is lambda, another one is lambda by 2, okay, and by having the relation between maximum kinetic energy of the emitted photoelectrons, right, in two different cases, that is what first case and second case, and it is right, it is in the second case it is 3 times that in the first case, in second case it is 3 times that in the first case. The work function of the surface of the material is, the work function of the surface of the material is dash, okay, right. See here, according to Einstein's photoelectric equation, according to Einstein's photoelectric equation, here in the first case k maximum 1 is equal to hc by lambda minus phi naught, hc by lambda minus phi naught, and that in the second case it is k maximum 2 is equal to hc by lambda by 2 minus phi naught, that is 2 hc by lambda minus phi naught, okay. And we are using the given relation, so you substitute these values in that relation, that is what it is k maximum 2 and it is k maximum 1, then finally we are getting phi naught is equal to hc by 2 lambda, okay, right. Next problem, that is what 35. See here, the slope of frequency of incident light and stopping potential graph, the slope of frequency of incident light and stopping potential graph, the slope of frequency of incident light and stopping potential graph for a given surface, will be, right. So that is you know very well, right, slope means y by x, no, m is equal to y by x, right. So whatever the quantity we have taken on y-axis to the whatever the quantity we have taken on x-axis, right. So y by x, that is nu naught v naught by nu is equal to h by e, so that you can see this one also, e v naught is equal to h nu, e v naught is equal to h nu. So v naught by nu is equal to h by e. This is what we got it here, that is the slope of frequency of incident light and stopping potential, right. So that you can see here, that is what v naught by nu is equal to h by e, v naught by e is equal to, right, v naught by e is equal to h by e, right. And the terms, many times I repeated, v naught is the stopping potential, right, and after that h is the Planck's constant and e is the charge of electron and nu is the frequency, okay, right. So this is what here you can select, they have given 4 options, so we have to select second option, that is h by e, okay, right. Next one, see here, 36th. And regarding the 35, I told you, see, when you are in first year also, I told you many times, while drawing a graph between two physical variables, right, we have to take independent quantity on x-axis, dependent quantity on y-axis, independent quantity on x-axis, dependent quantity on y-axis, right. So this is the thing generally we are doing when we are going to plot a graph between two physical variables, okay, right. Next problem, 36. See here, when a metal surface is illuminated with a light of frequency nu, the stopping potential for photoelectric current is V0. When a metal surface is illuminated with a light of frequency nu, the stopping potential for photoelectric current is V0. Okay, right. When the same surface is illuminated by, light of frequency nu by 2, okay. I will repeat once again. When a metal surface is illuminated with light of frequency nu, the stopping potential for photoelectric current is V0. Okay. When the same surface is illuminated by light of frequency nu by 2, the stopping potential is V0 by 4. So, two different cases, right? He is comparing like case 1 and case 2. When the same surface is illuminated by light of frequency nu by 2, the stopping potential is V0 by 4. Okay, full stop. The threshold frequency for photoelectric emission is, so we have to find threshold frequency, that is what nu naught we have to find. Okay, right. See here, according to Einstein's photoelectric equation, we know that is K maximum is equal to h nu minus phi naught, and we can also write E V naught is equal to h nu minus phi naught. Therefore, E V naught is equal to h nu minus phi naught, because in the first case, see here, right. So the stopping potential for the photoelectric current is V naught, and that is what light of frequency nu, that's why no change. So whatever is there, that you can write based on that situation given in the first case. And in the second case, when the same surface is illuminated light of frequency nu by 2, the stopping potential is V0 by 4. See here, E into V0 by 4 is equal to h into nu by 2 minus phi naught. It is like equation number 2, right? It is equation number 1 and it is equation number 2. Okay, from 1 and 2. So from equation 1 and equation 2, we get, that is what h nu by 4 minus phi naught by 4. H nu by 4 minus phi naught by 4 is equal to h nu by 2 minus phi naught. So here E V naught is there now. In place of E V naught, we are writing this value, because from 1 and 2, no. So from 1 and 2 means here it is what h nu by 4 minus phi naught by 4 is equal to h nu by 2 minus phi naught. H nu by 2 minus phi naught, or phi naught minus phi naught by 4 is equal to phi naught minus phi naught by 4 is equal to h nu by 2 minus h nu by 4. H nu by 2 minus h nu by 4, or phi naught is equal to h nu by 3, right? See, do this that is what here 3 phi naught by 4 will come. 3 phi naught by 4 will come. So here also you take that LCM. This is what 2 comma 4, right? And do this process mathematically. Then finally we will get it as phi naught is equal to h nu by 3, right? So threshold frequency nu naught is equal to phi naught by h, that is equal to nu by 3. Phi naught by h, that is equal to nu by 3. Nu naught is equal to nu by 3. Threshold frequency nu naught is equal to nu by 3. Okay, right. So this is what he is asking to find. Next problem, that is what 37. See here. The work function of metals is in the range of 2 electron volt to 5 electron volt, full stop. Find which of the following wavelength of light can be used. Find which of the following wavelength of light can be used for photoelectric effect. So here Here we have to know the definition of threshold wavelength, right? Definition of threshold wavelength, right? That is what the maximum wavelength of light, the maximum wavelength of incident light which is required for the emission of photoelectrons from a metallic surface, right, is simply termed as, that is threshold wavelength, right? So in this question he is asking to find out, he is asking to determine threshold wavelength, okay, right. The work function of metals is in the range of 2 electron volt to 5 electron volt, full stop. Find which of the following wavelength of light can be used. Find which of the following wavelength of light can be used for photoelectric effect. For photoelectric effect, okay, right. See here, for metal 1, right, in this case, I know, that is what ma. In this case, to find the threshold wavelength, lambda is equal to, that is what Hc, right, that is what the product of Planck's constant and then speed of light, see here, that is Hc by the value what they have given, that is what work function, the value is work function, okay, see here ma. So Hc, because this value is given in electron volt, no, so the product of Hc can write it as 1242, sometimes we are writing 1240 also, okay, 1242 electron volt nanometer, there we will get it as, there we will get it as 240 nanometers, right. So many times I told you while solving one physics problem, right, so we have to look at the options, right, especially while answering for Neet questions and mains questions, right. So we have to look at the options. Options are given in which units, which system of units, SI or CGS. So according to that we have to solve, right. So in this problem, because of giving options in nanometers, right, so which is not the CGS unit, which is not the SI unit, but it is the smallest unit, right, okay, that is what a smaller unit you can say, because when compared to nanometers, even smaller also there, that is what pico and Fermi, like, okay, right. Anyhow, the options are given in nanometers, that's why we have to solve the problem in nanometers, right. So for metal 1, it is lambda minimum is equal to, I told you, Hc by, this is what work function, so that is 1242 electron volts nanometer divided by, that is what 5 electron volt, that is equal to 240 nanometers. Then for metal 2, that is what lambda minimum is equal to, 1242 electron volt nanometer, 1242 electron volt nanometer divided by, that is what 2 electron volt is equal to 600 nanometers, right. So this is what I already told you the definition of threshold wavelength, right, regarding this problem. So what is the threshold wavelength? You can say that the maximum wavelength, right. So we have written here minimum and here minimum, okay, it belongs to that particular situation, but anyhow orally, right, so this will become as maximum, right. So in this case it is 600 nanometers, and in this case it is like what in this case it is 240 nanometers, and in the next case it is, right, this is what in this case it is 240 nanometers, right. Simply I put that is what lambda naught, because in both the cases we found wavelength, right. Afterwards we will decide, after completion of getting these two values, that is what in two different cases, we will find out that 600 nanometers is the maximum wavelength, and we can say that in case of 600 nanometers, right. So in the options they didn't give 600 but they have given 650 nanometers, okay. Anyhow, the answer what we got, 600 nanometers is close to 650 nanometers, so that you can say that with this value, right, with this wavelength, light, right, see here, find which of the following wavelength of light cannot be used for photoelectric effect, right? See here. So that is what you can say, which is 240 nanometers and which is what 600 nanometers, right? So that we got that is find which of the following wavelength of light cannot be used, right? Cannot be used for photoelectric effect. Okay, see here. So that is what okay. So that is what here cannot be used, right? So which of the following wavelength of light cannot be used for photoelectric effect means you can select this one. That is what 600 nanometers. Okay, right. Then see here, that is what if you take next problem, that is problem number 38. The threshold wavelength for photoelectric emission from a material is 5200 angstrom unit. Full stop. Photoelectrons will be emitted. Photoelectrons will be emitted when this material is illuminated with monochromatic radiation from a dash, right? See here, 38 question. The threshold wavelength for photoelectric emission from a material is 5200 angstrom unit, right? Full stop. Photoelectrons will be emitted when this material is illuminated with monochromatic radiation from A, right? See here. So first you have to understand the question, and afterwards if you observe carefully what he is asking, see here. Photoelectrons will be emitted when this material is illuminated with monochromatic radiation from A. From A, right? So they have given options, so 5 options they will give us. So it is like a trial and error method, right? So first option I did it right there, but you please listen carefully, So first option they have given like 50 watt infrared lamp, and second option is like 1 watt infrared lamp, and third option like 50 watt ultraviolet lamp, and fourth option like 1 watt ultraviolet lamp. Okay, and fifth option is like both 3 and 4, right? So students, I request you one of the small thing, regarding 37 and 38 problem, you please try to understand. Okay, already we discussed many times, but once again I want to say, right? So what is photoelectric effect? What is threshold frequency? What is threshold wavelength? And what is the relation between the wavelength of the incident light and what is the relation between the frequency of the incident light? Okay, and the rest of the quantities, those are like kinetic energy and work function. At the same time, the relation between intensity, that is what energy of the incident light, and then work function, afterwards kinetic energy. So these relations between various quantities regarding the photoelectric effect we must keep in mind to answer for 37 and 38 questions, right? The questions are not difficult, but the problem is understanding, right? So if you understood that relation, it is easy to answer. Okay, right? Now you see this question, that is what question number 38, right? Question we discussed now. So now we are going to see the answer. Okay, right? See here. So that is what he is saying. In this case, the photoelectric emission, the wavelength of incident radiation. In this case, for photoelectric emission, the wavelength of incident radiations must be less than 5200 angstrom unit. 5200 angstrom unit. Okay, full stop. Wavelength of ultraviolet radiations is less than this value, that is what 5200 angstrom unit, but wavelength of infrared radiations is higher than this value, right? So what is the wavelength of ultraviolet radiations and what is the wavelength of infrared radiations, that we know. So we have to compare this value with the wavelength of infrared radiations and wavelength of ultraviolet radiations. Then we can get the conclusion. That is what here, regarding this situation, what they have given in the problem, 50 watt ultraviolet lamp and 1 watt ultraviolet lamp, emission of photoelectrons takes place, right? So in the case of 50 watt ultraviolet lamp and 1 watt ultraviolet lamp, emission of photoelectrons takes place. Emission of photoelectrons takes place. Okay, that is what we can say. Okay, right. So see here, regarding this class 34, 35, 36, 37 and 38. Okay, so in first problem, by giving a situation, that is what for one photoelectric surface, regarding the two different wavelengths of light, he is asking to find work function, right? So that, see, that is like equation 1 and equation 2, like by solving these two equations. Okay, I didn't write here equation 1 and equation 2 but anyhow from these two, right, first case and second case, and by using the relation given in the problem, we found work function in terms of hc lambda, that is phi naught is equal to hc by 2 lambda. Then in the next problem, that is what 35, the slope of frequency of incident light and stopping potential graph for a given surface will be, right? It is simple like theoretical question, and in our motion in a straight line chapter and laws of motion work power energy in our first year, right, many times we calculated the slope from a given graph, right? The same thing you apply here. And one more important point is we have to take dependent quantity on x-axis and independent quantity on x-axis, right, dependent quantity on y-axis, right? So sorry for saying wrong, I will repeat once again. While drawing a graph between two physical variables, we have to take independent quantity on x-axis, dependent quantity on y-axis, right? So from these two things you can say V naught by nu is equal to h by e, because V naught by nu will give us slope, right? Next 36th problem. In 36th problem also we have two different cases, and by having this formula, and if you apply this formula to two different situations, we are getting two equations. By solving the two equations, you can say phi naught is equal to h nu by 3, and finally he is asking to find threshold frequency, right? So then threshold frequency will become as nu by 3, okay, right? Next 37th problem, right? Once look at this problem, he is asking which of the following wavelength of light cannot be used for photoelectric effect. That is the question, and I request you to follow, to get or to keep in mind the relations between various factors, regarding the factors or physical quantities we came across with respect to photoelectric effect phenomena, right? So in that way you just observe here, so in one case it is what 240 nanometers, in another case it is 600 nanometers, right? So you can choose 600 nanometers as the answer according to the question. Next 38, okay, next question, see here. So here he is asking, by giving one respective wavelength 5200 angstrom unit, asking to find when photoelectrons will be emitted, right? Okay, and you can say that in these two cases, that is what in case of 50 watt ultraviolet lamp and 1 watt ultraviolet lamp, the emission of photoelectrons will takes place, okay, right? And in our next class we will continue with next continuation problem 39, okay. Thank you.